Okay, good day. So today, fluid mechanics is our subject. So I'm your professor, Engineer Pancho Prientos from the Mechanical Engineering Department. Okay, why do we need to study fluid mechanics? So when you hear the word fluid, so pumapasok sa utak natin is liquid. But we're in fact fluids, kasama po yung gases dito class. Okay? And also mechanics. So engineering mechanics natin, we have to do branch the statics and the okay. So what is fluid mechanics? Actually, that is the study of fluids either in motion, sabi ko nga, fluid dynamics tinatawag yon, or either at rest. So fluid statics yon, and the different subsequent effects of fluid upon boundaries. So pwedeng solid yung surfaces mo or interfaces with other fluids. Okay? So what are the different applications of fluid mechanics? So more likely, both gases and liquids are classified as fluids. So tatandaan natin yan. And we have different fluid mechanics, fluid engineering applications. So the very first is our breathing. So we breathe in, breathe out, inhale, exhale. So that is the application of fluid mechanics. And also the blood flow, wherein our blood flow, it is where our blood flow all throughout our body. So swimming, when we are swimming, so meron dun na buoyancy, the weight of the body. So may computation down class. And we have pumps, fans, and turbines. So basically, mahahanap to sa different power plants wherein fluid mechanics ang nagpapagana. Okay, sa turbines natin, when the steam enters the turbine, it will generate electricity. Okay, the airplanes, paano ba umaangat yung aeroplano? So, aerodynamic, may lift, may drag, automatically, fluid mechanics din yun, guys, because the air is a gas. And the reverse, fluids, windmills, also air, the pipes, the missiles, icebergs, engine, filters, jets, and sprinklers. Okay, yung sprinklers class in our subject or in our field in mechanical engineering, more likely, pag may trabaho na kayo, you will always hear the word maps. So, mechanical and fire protection system, the system of a certain building. So you need to compute for the first one. You need to design what pump you will use in your fire protection system. So you will compute for the remote area of that. So hydraulic calculation ang tawag ng class. You need to locate the very remote area or the most remote area. You need to calculate the pressure head and the different pressure in the pipelines, okay, of that fire sprinklers. So sabi niya dito, when you think about it, almost everything on this planet either is a fluid or moves within near fluid. Okay? So what is the cause of fluid? Actually, from the point of view of fluid mechanics, all matter consists of two states, the fluid and solid, compared to the point of view of science that, kasi broad pa yung class matter. So solid, liquid, and gas. But here, fluid mechanics, it consists only of two states wherein that is a fluid and solid. Okay? So meron tayo dito technical distinction na to with the reaction of two to an applied stress or tangential stress. Yun lang yung stress. So, papasok dito yung tangential stress and shear stress. Okay? Madaming computation dito. Okay. So, a solid can resist a shear stress by static deformation. A fluid cannot. So, balikan lang natin in your mechanics of deformable bodies. Tama ba? Okay? Naka-mechanics ako. Okay, anyway. So, the definition of a shear stress is the tangential force divided by the area. Okay? So, any Any shear stress applied to fluid, no matter how small, will result in motion of that fluid. So, alam din natin na ang fluid nagmo-moves and deforms continuously as long as the shear stress is applied. So, meron pala yung shear stress doon, class. But we can say when the fluid is at rest, automatically, nasa state of zero shear stress din siya, class. Okay. Ang kadalasan ang tawag dito is the hydrostatic stress condition in structural analysis. But here in our subject, kung meron ang fluid mechanics na ang civil, so sa atin, more likely papasok dito yung sa pumps, turbines, and the fire sprinkler protection. So what are the two classes of fluids? Yan. So the first one is the liquids. We all know that liquids, the forms, gases. So what is the effect of cohesive force? So this is just an introduction to you about fluid mechanics. So a liquid is composed by relatively closed molecules with strong cohesive forces tends to retain its volume and will form a free surface. Automatically, kung ano yung, ito yung bote mo, automatically kung anong shape niya, yun na, alam niyo na yan. So, may cohesive forces dito. Ibig sabihin, compact yung mga molecules dyan compared to solid na mas compact talaga. Okay? Since gas molecules are widely spaced with negligible cohesive forces, a gas is free to expand. Okay? So, meron tayong free expansion of gas. So, sabi dito, a gas has no definite volume. So, wala. Nakukompute lang siya in a certain area where it is also confined in a certain space. So, basically, yung properties natin is the next topic we'll discuss. Okay? So, gases cannot form a free surface. Okay? So, mga gravitational effects lang siya compared to buoyancy. Okay? So, this is the concept of fluid wherein pinapakita lang dito pag ang pinagkaiba ng sa solid and sa liquid yung static force natin and the different static deflection. Okay, class? So, here's this an illustration wherein the static deflection at solid wherein you can see, okay? And on the other side, you can see the liquid and the free surface and the gas which is open to the atmosphere. Okay? Pinakita dito na meron tayong element A on the side of black. Kasi class may static deflection yan, automatically, yung stress natin is equal to the negative P. Okay, dyan. Pinapakita. Okay. Compare daw sa liquid and gases, kailangan natin ng supporting walls para ma-eliminate yung shear stress. Okay? Pero makikita mo dito, sa bilog kanina sa more circles, mayroon tayong tinatawag zero shear stress, hydrostatic condition. Automatically, yung free surface natin sa container, if the walls are removed, shear develops in the liquid and a big splash results. Diba? Automatically, pag siya, pag nagalaw siya, automatically mag-splash siya. Okay? So, madami pa rin. And meanwhile, yung gas is unrestrained and expand out of the container, automatically, yung compression natin nangyayari and the hydrostatic. Okay? So, pinakita ko lang doon kung paano nga ba, ano pinagkaiba ng solid, liquid, and gas. Okay? And also, the fluid as continuum. Bakit tinatawag na ang fluid natin as continuum? So, fluids are aggregation of molecules widely spaced for gas, closely spaced for liquid. So, also the distance between molecules is very large compared to with the molecular diameter. The molecules are not fixed in lattice but move about freely relative to each other. And also, fluid density or mass per unit volume has no precise meaning because the molecules occupy a given space. Okay, so sabi ko nga, fluid density has no precise meaning because the number of molecules occupies a given volume
specifically changes. Okay. So when we say in our fluid mechanics, it is convenient to treat gases and fluids as continuously because all throughout the region dapat parehas sila. Okay? So that is continuously distributed all throughout the region. So kaya tinatawag yung fluid as continuum. Okay? So here is a definite example or illustration wherein density is the very important fluid property to be considered as a continuum. Okay? So, pinakita ko lang dito yung computation. May limiting volume. Okay? So, such a fluid is called continuum, which simply means it is okay, so which simply means that its variation properties is so smooth that the differential calculus can be used to analyze the substance. Okay? So, dapat pasado na tayo dito sa calculus and the integral calculus. Okay? Okay? So, in fluid mechanics, we need to compute for the different problems involving fluids. So, we need to understand the difference between the dimension and the units. Dito, dimensional analysis is very needed. Okay? So, madaming kailangan i-analyze mo dito. Where in fact, gagamit tayo dito ng yung kilogram natin is M and ang dimension niya is kung ang dimension is mass, ang unit niya is kilogram. Kung ang dimension is length, ang unit niya is feet or meter depending upon the system, the English system or the SI unit. More likely, kailangan natin ng dimensional. So here is a simple history of dimension in units. So metric convention, we have used the British system, the base foundation of the 10. Okay, so meron talagang metric na nagagamit. So kilopounds instead of dimes or newtons, kilograms instead of grams or calories, or instead of joules. So here's the brief history. So, in 1960, na-standardize yung metric system natin. So, sa 40 countries. And also, in 1974, SI unit na are na-publish ng ASME, or the American Society of Mechanical Engineers. And now, so, transition to SI. So, madaming adjustment ang nangyayari. So, depende na lang kung kaya nga sabi ko, you need to solve problem in SI or in British system. So, meron tayong primary dimensions sa fluid mechanics, mass, length, time, and temperature. In SI, kilogram, meter, second. So, why Kelvin? Because in thermodynamic temperature scale, we make use of Kelvin. Okay, in the British system, we have slug, foot, seconds, and Rankine. Okay, alam niyo na yung mga conversion factors niyan. Here, we have 1 Newton is equal to 1 kilogram mass per second, and 1 pound force, 404.44.82 Newton. So here is an example of a dimensional analysis where is force is equal to the mass times the length over the time. Diba? Kilogram meter per second squared. Time to. Time squared yun plus. Kasi over. So, sa next topic natin, I will discuss the different dimensional. Okay? So, this is also the secondary dimension used in fluid mechanics. Ano ba yon? So, you need to know the different conversion
we can make use of this or make use of my example. So here is an example. I will not discuss this here because I will upload a separate video explaining the problem solving. So we need consistent units here. So dapat alam natin na dimensionally homogeneous yan. So we need to check for that. Okay? So meron din tayong British Thermal Unit or yung BTU natin. Kailangan natin yan. Okay? We need to convert that. And we also know that homogeneous consistent equations versus dimensionally consistent equations. So more likely, this is just a reading wherein you can use the constant. So we make use of a constant. For example, here, the valve coefficient, the valve flow coefficient was infused so that masatisfy natin yung equation. Okay? We also use the different prefixes of 10, the powers of 10. Why? Because the megapascal, the kilopascal are more likely to be used. Okay? So, para hindi ka naman gawa-gawa ng madaming zero dyan, bibilangin mo pa. Okay? So, here are the prefixes of the convenient prefixes in powers of 10. So, pag 10 to the negative ato, 10 to the negative femto, pico, nano, micro, millicentid, deci, deca, okay? Hecto, kilo. So, this is more likely the kilo, the mega, the giga, and the tera. Okay? This is another example. Separate video will be uploaded right here. Okay, so thank you. So that is just a different introduction here in fluid mechanics. Okay, stay tuned class. So I hope everyone will really listen to this video. So thank you and God bless.